Finally, let's look at the effect of wind on microclimate. So we all are thinking about how when air blows through a room or through a yard, it makes things cooler. And that is true if the air is cooler than the objects. If the air is the same temperature as the objects, obviously it can't remove any heat. So if you're in a hot, dry climate, wind will not cool you. However, if you can add water, like you find with a water feature in a courtyard or some of those spray misting nozzles like you see in outdoor plazas, then you have evaporation. Evaporation is the principle of refrigeration. It can lower the temperature of objects. In the summertime, you want to carry heat away by blocking terrestrial radiation and by increasing the wind flow. So here's a residence where you might want to figure out where to put things like plants that will help funnel that wind through there. In the winter, of course, you don't want cold wind, so your idea is to reduce the wind coming in, and you might even want evergreens on the side right where the wind comes in. Air is a fluid, as is water, and so air flows around objects on the earth just like water flows around objects in a stream. So you can picture that as you're thinking about where is the wind going to go. One thing that happens is warm air rises. It's less dense, it's more buoyant, and so in the daytime, wind will blow uphill from valleys. Conversely, in the nighttime, cool air is denser and it will flow down a valley, and you can see some dramatic illustrations of this in some of these. I think they call these tablecloth fog. You might search a Google image search and see what you can find. So how this affects you is if you have a building down here in the bottom of this valley where cold air is going to flow down here, now that might be good if you're in a place where you want to be cooled down. It might be cold though, and especially if you have an object down here that acts like a dam in a stream, it will trap that cool air, and you might wake up in the morning to find things are really cold. Here are some diagrams of these phenomena from Utah State. You can find out what direction the wind is going to blow in your particular site, and you can find with what speed it's going to blow. These objects here are called wind roses. They are graphs of the wind, and you can find graphs at this URL, at this website. These graphs up here happen to be wind roses for Eugene, Oregon. And this one in the upper middle is a graph in January. So you can see the longer arm means more velocity, and south shows true south. Then this wind rose here in the upper right is for July in Eugene, Oregon, and you can see, oh, it's shifted direction. It's not quite as fast a wind, but kind of, and it shifted direction. Here is true north. The reason we're seeing Eugene, Oregon here by coincidence is that Charlie Brown, that's what we all call him, GZ Brown. Charlie Brown is an architect at the University of Oregon who's a national expert on managing energy, light, heat, airflow, and so forth. He's written this book it's got a new edition now, Sun, Wind, and Light, and he has a laboratory at the University of Oregon in the architecture program that studies these things. He also did the light and some of the other energy studies for the Health and Wellness building on the LCC campus and for the downtown center. So you'll see I have several drawings in here from Charlie Brown's book where he's showing you what happens to wind as it flows over objects. And just like water in a stream, you'll notice when it gets past a solid object, you get some turbulence in there. And here's some more diagrams. This is from a mechanical system design book showing about turbulence and about how if you have an object with holes in it, the wind can flow through. You've probably heard about this urban canyon effect, especially in the city of Chicago, where there are tall, solid buildings close together, and the wind comes blowing through there, and just like gasoline in an old-time carburetor, there's a Venturi effect. So when the space that the air flows through necks down, the velocity increases, and you get this high-speed wind flowing through there. That is one of the reasons that the city of Chicago now has a design guideline that says buildings along streets must be stair-stepped back. You can't have just a vertical wall now, and you'll notice that in some of the photos. I just want to show you this interesting demonstration of the canyon effect. So I was on a campus tour at the University of Pennsylvania a couple years ago. Beautiful campus, lovely setting. But out on the edges of the campus, there were some of these, recognize this style, international style? There were some of these international style dorms that were built in the 70s, back before we knew as much about the wind effect. So anyway, we were all walking through the campus and it was beautiful, and we all had this is us here. We had file folders and notebooks where we were taking notes, and we got to this stretch right in here in between these two dorms, and all of a sudden this blast of wind came up. Everybody's papers went flying. You couldn't write anything. So we asked the architect about these, and he said they haven't decided what to do about that yet. They recognize it's a serious problem. One of the options is demolish one of the dorms. They don't know yet. So it's common to use trees as windbreaks, and these are some diagrams that show how much the wind speed is reduced at what distance out away from the tree, measured as a percentage of the height of the tree. Again, if your wind is coming from the north in the wintertime, that's where you probably want to put your evergreens. Out on the northern plains, like in South Dakota, where it gets really cold and those winds come whistling across the plains, you'll find a lot of plants planted as windbreaks. And you notice that they are planted in layers with space between them and varying heights. The reason for that is that you slow wind better. Well, here's a diagram. If your wind barrier has pores in it, has holes in it. Now, this is the opposite of what you want when you're trying to block noise. So you'll notice on a freeway, noise barriers are solid material. Trees don't do a very good job of blocking noise, even though psychologically we think they block it. But when you're trying to block wind, you do want things with holes. So trees work a lot better than solid walls.